So here's something else I want to go over, just in case she decides to throw you a loop on an exam. This question, I think, was on the worksheet, and it was supposed to ask you what type of orbitals form the triple bond between this carbon and nitrogen. This is, if you've been studying, you know this is a nitrile. You will definitely see this again. Not so much in comparison to like the carbonyl bond and stuff, but this is definitely going to have some significance in organic too. So we want to figure out what type of orbitals make this bond and draw them out. So we know that both of these atoms are surrounded by two effective pairs, so they're sp hybridized. So whenever something is sp hybridized, it has two sp orbitals. So you have the s orbital and the p orbital, and then they add together to make two sp orbitals. So I'll just draw them like gumdrops or something. Two sp orbitals, and that completely consumes the character of the s orbital. So the only thing you have left for the other two orbitals is going to be the two p orbitals, because every period 2 element is going to have one s orbital and 3 p orbitals to use to make bonds in any molecule. So at the carbon-hydrogen or carbon-nitrogen interface, let's go ahead and draw it out. So you have carbon and nitrogen. The sigma bond is always going to be, or this bond, I guess, in the middle here, is going to be composed of the sp-sp orbital overlap. Just head-on overlap of the orbitals. So you just draw on your sps. Make sure you label your orbitals. And then you have, let's see, we're only focused on this middle part of the bond, but keep in mind that the other sp orbital, because each of these has two sp orbitals, right? The other sp orbital is going to, for the nitrogen, it's going to contain this lone pair. This is going to be an sp orbital. And then whatever this carbon is attached to, so say it's like a hydrogen. Say we just have just some hydrocyanic acid or something. So the other sp orbital right here is going to comprise this bond. So now we're only focused on the p orbitals that make the double bond. So each one of these is going to have a p orbital like in this up and down plane. It's going to have another p orbital here for both of these atoms, and it's also going to have one that's kind of like flipped over or flipped on its back, coming with one end coming out of the page. So here's the bottom end coming out of the page. And then same thing for this one too. Goodness, I hate drawing. All right, so this one is up and down. And then this one's going to be back and forth. And then this one's going to be up. And this one is laid on its back. Again, with this bottom part coming towards me out of the page or towards the camera, and this one going away from here, like I guess down into my bed. So basically, when these two combine to make a bond, these orbitals overlap. And it's going to look a little bit like this. So you have your carbon end. sp orbital overlap is kind of encompassed inside the p orbitals. But here's your sp-sp to your nitrogen. And these pi orbitals overlap such that you get a space, or the p orbitals, my bad. So this is your pp orbital. And there's also a probability of electrons being beneath the carbon nitrogen little interface here. So basically what happened was this came from the top part of two p orbitals overlapping. So these two tops right here, 1 and 2, came in to make that. And then the bottoms made this. And this is just from the up-down. The up-down p orbitals. The back-forth p orbitals also do the same thing. So they basically, this is very three-dimensional. So they're basically going to form a case around this whole carbon-nitrogen interface with the sp-sp bond. So they kind of encase this thing. So there's one in front, another pp, and then there's one in the back. So I'm just going to draw like way back here. One behind. And those are all of the orbitals that come in to form this this nitrile bond, the nitrile triple bond. This is really poorly drawn. But just, so this is basically like, it's basically a sandwich. You have these pp, these pi bonds, because these are the pi bonds, right? These pi bonds are the bread. And the sp-sp sigma bonds are like the meat and the cheese and all that. So whatever you get at Subway. And the same thing happens here from front to back. You got two pieces of bread in the front and the back, and the SP. So this is like a really complicated sandwich. I probably wouldn't eat it. Probably something you get at like KFC, like what is that sandwich where they put like chicken and sausage and bacon on it, and it's just death waiting to happen. It's like something like that. Like this sp-sp bond is essentially like completely shielded by these orbitals. And keep in mind that these orbitals are just imaginary, sort of like imaginary little regions of space that basically just describe the probability of where the electron could be. So the electrons from the top bottom, the top bottom pi bonds could be either above or below the carbon-nitrogen bond interface, but they can't be in it because there's a node there. So a node or whatever. Because you see how these kind of intersect at a point. The nodes are places where where there's no probability of finding an electron at all. And then the same thing happens with the p bond, the other pi bond that's basically oriented perpendicular to the up-down pi bonds. Anyway, this sounds like it was kind of confusing. If I confuse you at all, just stop watching and just erase this from your mind. This is supposed to help, not hurt. Good luck.